This demo showcases Snowflake and TrustLogix securing a multi-agent autonomous pipeline. The example is a next-gen network operations center where autonomous agents diagnose issues across the radio access network and then triggers a proactive dispatch workflow for maintenance. The demo will show that every step is tightly governed, enabling powerful automation without compromising security. So step one is to register the agents in TrustLogix. This is basically defining which agents we're going to secure. To do this, we capture the identity of the agent. That identity can come from Entra ID or Okta or any other identity provider. Next, we define the purpose of the agent. In this case, it's a diagnostic agent. And here we define PII as restricted data. We're integrated with Snowflake Horizon, so if the data is tagged as PII in Snowflake, we recognize this, and at runtime, if the agent tries to access something with that PII tag, the policy will deny it. Next, we'll define access controls on the datasets. Here you can see we're using the TLX Telco Customer and Support dataset as well as the Telco Network RAN dataset. Access can be granted based on purpose, region, and other attributes you can add. In this case, the agent can only access data for specific regions and cell tower IDs. For this demo, we're going to intentionally set the agent role incorrectly, assigning it as customer notification instead of the correct role, which should be network diagnostic engineer. We're doing that on purpose to show how the policy engine evaluates a mismatch. As soon as the agent is initiated, it connects to the Snowflake Cortex agent. From there, it connects to the TrustLogix MCP Server, where the policy evaluation happens. It then evaluates the configured permissions, purpose, role, and user attributes, and verifies database access. And here, the check passes and proceeds with invoking the Snowflake Cortex agent. In this demo, we're showing Cortex Compute executing on the back end to illustrate that it has the proper privileges to perform the diagnostics. So now the Cortex agent is ready to move to the next phase, which is invoking a second agent to provide an autonomous dispatch response for the diagnosis it just did on the radio access network. At this stage, the second autonomous agent's policy is evaluated, and recall that we intentionally configured the role incorrectly, and so it's blocked. So the Cortex agent is not invoked, and we receive an access denied due to insufficient permissions. We then go back and correct the policy, updating the agent role to the proper one, network response agent. And once that's corrected and the agent reruns, the policy evaluation passes and the Cortex agent is invoked for the response phase. Now the agent role has been corrected, the policy evaluation passes as expected, and the Cortex agent is invoked for the response. Cortex executes, returns the results, and now we see the dispatch schedule identifying the sites that require maintenance or emergency support. So this shows the power of a multi-agent autonomous system operating end-to-end with rigorous role, attribute, and purpose-based access controls governing every step of the process. The key takeaway is that traditional role-based access control is not sufficient for autonomous agents. These agents are dynamic. Access decisions must consider purpose, agent attributes in the context when invoking the agent. Static RBAC is just not a solution. Autonomous systems require contextual machine speed policy enforcement, and this is what Snowflake and TrustLogix delivers.